Alrighty, good morning, Algebra Tours. Today I'm taking a look at graphing quadratics using something called standard form. Now, standard form of a quadratic function is written like this. Y equals ax squared plus bx plus c. This is standard form. Now, I know this is quadratic because I see an x squared, right? That's how we recognize quadratics. Okay, that's magic pen. Right? Now, how do I go about then changing standard form to what we're used to seeing, where we can see the transformations? In this form, y equals ax squared plus bx plus c, I cannot see the transformations. So I need to be able to see the transformations of a parent function, which normally look like this. Right? Now, I'm going to teach you how to change standard form, y equals ax squared plus bx plus c, to this transformational form, what we call vertex form, in this lesson. Now, again, if you forget about the transformations and how we graph a parabola or other functions using transformations, I encourage you to re-watch. There were 3 screencasts on parent functions and how to transform them. Okay? Alright, but I want to do one quick review with you on how we graph a parabola or a quadratic using transformations. Alright, well, I know that the parent function is y equals x squared. And we know that the xy table for x squared is -2, -1, 0, 1, and 2. When I plug these values into this function y equals x squared, I would get 4, 1, 0, 1, and 4. On a graph, the graph would look like this. Graphing these 4 points out, I get -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then I would draw these with as smooth a curve as I could so that it looks like a U. Okay? So I know that's what the original parent function looks like. Then we said, okay, if I take this original table of values and I apply the 3 transformations that I have, I would get this. And I want to cut to the chase here. I know that my h is 1, and so that tells me that I need to shift all my x coordinates of each point to the right 1 unit. And so what that means is I would have to add 1 to all these x values. So I get -1, 0, 1, 2, and 3. Now, on the opposite side, what am I doing to the y? Well, I'm multiplying all my y's by a half. So if I take half, I multiply all my y values by a half, I get 2, 1/2, 0, 1/2, and 2. But then I still need to do one more transformation to my y values. Doesn't this say I have to add 3 to all my y values? So I get 5, 3.5, 3, 3.5, and 5 again. And so now just focusing on the outermost columns, my x's would be -1, 0, 1, 2, and 3. And my y's would be 5, 3.5, 3, 3.5, and 5. So instead of this parent function being my graph, I now would have a graph that looks like this. -1, 5 would be over 1 and up 1, 2, 3, 4, 5. 0, 3.5 would be up 0 and 1, 2, 3.5. And then 1, 3 would be right here. And then 2, 3.5 would be right here. And then 3, 5 would be back to here again. And there's my smooth parabola that you can see that I've graphed there. And that's how we graph the transformations of a quadratic. Now, what we want to look at next is how we change standard form to what we call vertex form. Now I remind you that vertex form, this vertex form that I talked about, well gosh, that's just your parent function with the transformations. So how do I change y equals ax squared plus bx plus c to this new form? Well, to do that, I'm going to complete the square. Right? Now again, the purpose of completing the square, ladies and gentlemen, is to change an equation that has two x's in it down to one x. Now here's the important part. When we complete the square, we're not actually solving, right? But as I told you, completing the squares, its purpose is not to solve. Its purpose is to go from two variables down to one variable. So watch what I'm going to do here to complete the square. I'm going to complete the square on the y equals ax squared plus 8x minus 7 side, right? Well, to do this, the first thing I do is I pass the 7 to the other side of the equation. So if I add the 7 across, I get y plus 7 equals x squared plus 8x plus, don't I want to add my own number in there, plus blank? But if I add my own number in there, I have to add my own number to the left side. I don't know why I just put a plus 7 there. It's early in the morning. Plus blank. Now, to figure out what this number is to complete the square, I take half of the middle number, 8, I divide that by 2, I get 4, I square it, and that's what I'll add to the left and the right side. Now, again, the reason why I wanted to put 16 there is I promised you that whenever you complete the square, the x squared plus 8x side, he will always factor into a nice and simple parentheses squared. Well, that would be x plus 4. And in fact, a little concept I told you is this second number in the parentheses is half of that middle number. Now on the left side, I'm going to simplify this. Y plus 7 plus 16, isn't that y plus 23? Well, we're almost home. So I get y equals x plus 3 squared minus 23. Well, again, ladies and gentlemen, if you look at this now, isn't this the parent function with the transformation showing? Where in this case, I only have two transformations. I've got the plus 3 and I got the minus 23. Now, if I take my parent function's xy table, negative 4, negative 1, 0, 1, and that's not right. Negative 2, negative 1, 0, 1, and 2. X, Y, negative 2, negative 1, 0, 1, and 2. And then 4, 1, 0, 1, and 4. If I apply the transformation, the first transformation that I would do is the plus 4. Now don't forget about my Kansas City shuffle, correct? If it says plus 4, I'm actually going to subtract 4 from all these x values. So I get negative 6, negative 5, negative 4, negative 3, and negative 2. Now to the right side, I'm going to subtract 23 from all the y values. 4 minus 23 is negative 19. 1 minus 23 is negative 22. 0 minus 23 is negative 23. 1 minus 23 is negative 22 again. And 4 minus 23 is negative 19. Okay? And then from here, I would just graph the xy table out. Negative 6, negative 19, negative 5, negative 22, negative 4, negative 23, negative 3, negative 22, and negative 2, negative 19. And those would be the points that I'd graph out. Now, I'm not going to actually graph these out because these are what we call ugly values that you'd want to graph out. But you know how to graph points. Now, my last comment that I have to say about this, ladies and gentlemen, is when we look at a parabola, ladies and gentlemen, we know that this middle point 0, 0, this is the vertex, right? Well, that'll always be the case. I know that the vertex of this graph is still going to be that middle pair of points. This will still have to be my vertex. Okay? Okay, and so that's how you change a quadratic in standard form to a quadratic in vertex form, which shows the transformations easily. Okay, let's move along. Let's look at another example. So I've got y equals 4x squared plus 16x minus 1, and I want to graph him. Well, again, I know it's quadratic because of the x squared, but I don't want to have to try and graph him in this form. I want to try and change him to vertex form. But as our astute student Susie said, I had told you that you can't complete the square if there's a 4 there. But Susie said, Chris, you can. You just have to divide everybody by 4, right? So watch how I'm going to do this, right? To convert this equation to standard form, what I'm going to do is I'm going to first move the 1 to the other side because you can't complete the square with that number that we don't want there. And then I'm going to factor out, I'm not going to divide out, I'm going to factor out a 4 from this right side. Now again, the reason why we do this is we want to add our own number to the x squareds and the 4x so that I can complete the square so that I factor into a parentheses squared. Now if I add a number to the right, I have to add a number to the left. And again, to figure out that number, I take half of this middle number, I divide that by 2, I take that answer and I square it, and I add it to the right side. Now this is the part you really need to focus on. It looks like I added 4 to the right side, correct? You see that 4 that I added? But if I were to redistribute this 4, wouldn't I have actually added 16 to the right side? Does that make sense? So in fact, I'm adding a 16 to the right side because of that 4 on the outside of the parentheses. So if I add a 16 to the right, I have to add a 16 to the left. Now again, the purpose of completing the square is to take this parentheses and factor it into a single parenthesis with only one x in it. Well, that would become x plus 2 squared. And on the left side, I would just simplify that to y plus 17. Well, from here I would get 4 parentheses x plus 2 squared minus 17. And now I have my vertex form, which shows my transformations. Again, using the xy table, I go -2, -1, 0, 1, and 2. I've got one transformation to the x's, which would be left 2, so subtract 2. So -4, -3, -2, -1, and 0. To the right side, I've got 2 transformations to the y's. I have to multiply by 4, right? And that would be 4, 1, 0, 1, and 4. I would get 16, 4, 0, 4, and 16. And then lastly, I would subtract 17 from all those numbers, which would give me -1, -13, -17, -13, and -1 again. So the graph of my transformed function would be -4, -1, -3, -13, -2, -17, -1, -13, and 0, -1. And that is, I'm sure, how you would graph. I know you know how to graph those points out. You should get a U using this point, right? Then you would graph those points out. All right, ladies and gentlemen, we'll talk more about this later in class. Bye-bye for now.